Thank you. Much easier to read. Everybody hear me okay down the back there? Yeah? All right, so lucky last for me, which is excellent because it means I've had a few beers. Going to do an introduction to Swift on the command line and Swift Package Manager as discussed. My name's Rob, or Bok, as most people here probably know me. That's my Twitter handle as well. If you do follow me on Twitter, earlier tonight you might have noticed that I said I was going to experiment tonight. As you can see, I'm attempting to keep the slides and my terminal, and as well as my IDE on the screen all at the same time. As such, here is my presenter's display with a very poorly hacked together app, which has an off by one error, so I'm already in trouble. You can get larger text on the terminal, Matt. Does that work? Want to go better? Go better. The more I go, the less you're going to have space for actual text.
People are bad. And blind people.
And blind people like you, sure.
Yep.
All right, cool. So there's my off by one error. Hooray. What we're going to look at very quickly, and when I timed this yesterday, I went well over time, so I'm going to skip through a lot of stuff that's not specifically related to the Swift on the command line or Swift Package Manager. But we're going to build a very simple Swift tool. I know it's in front of me. What am I looking at the screen for? Going to use Swift Package Manager. It will accept command line arguments. We'll have some subcommands in there as well, like a git pull or your git clone, that sort of thing. It will accept standard input, and it will execute out other programs. So this is fairly standard application. Where am I up to? Not included. So I'm not going to talk about Swift on Linux. Even though Swift and Swift Package Manager is designed to run on Linux as well, I'm not going to touch it. We're going to import Foundation because everybody loves Foundation. So these are Mac-only command line apps. So this is what we're aiming to do. Now I have to apologize to Matt because I know you wanted me to try and replace Fastlane with Swift, but that was a terrible example. So we're going to do a very simple JSON parsing application that basically lets you minify, pretty print, or render a Mustache template using the supplied JSON data, and we'll throw in a couple of the standard version and help options so we can see how that all works. So let's get started. Over on the right-hand side there in the terminal, you can see empty directory. To create a Swift package, we go Swift package init. We specify a type, which is executable. There's other packages, options like libraries and that sort of thing. But for us, we're going to go executable. So just a quick rundown. The package.swift replaces your Xcode project file, manages your dependencies, your targets, that sort of stuff. Your sources directory has all your source in it, clearly. It's usually one target or one module per directory, per subdirectory. You can see it created the JSON subdirectory in there. So that's our executable target. There's a test folder. So yes, you do still have to write tests. You can't palm that off. And then there's a hidden .build folder as well, which is what the Swift Package Manager uses to manage its dependencies, as well as its derived data and that sort of stuff, and a few of the other boilerplate Git project repo stuff. Where am I up to? There, cool. So, brief look at our architecture of this app. It has one target at the moment, which is our JSON target, but the problem with that target is it's not testable. For whatever reason, when you attempt to run tests, you cannot import that, that target. It just doesn't generate the symbols or something similar. So your best bet is to keep your JSON very minimal and wrap everything up into a library target that you can test. In this case, I like to call my base one core. Call it whatever you like, it doesn't really matter. JSON kit. No, because the sole purpose of this target is to do command line parsing and then to call out to the other frameworks that we have there. So I like to put my subcommand logic into its own target so that it's separate and testable, and then the core one just wraps that basically handles passing arguments, calls the correct framework. Cool. So this is going to be a live demo the whole way through, so let's just hope that this works. Step 1, let's add our core package. Now we have an IDE over here. Hopefully, I know you probably won't be able to see the file browser on the right-hand side there, but you should hopefully be able to see the code at least. So inside our package.swift, this is the standard out-of-the-box one. Let's replace it with something a bit more condensed. We have target name, the output binary. Dependencies, we have no dependencies at this stage. And we have 2 targets. We have our executable target, which is the name of the binary. And we have a library target, which is our core library target. And obviously, the executable target will depend on the library target. So that's all well and good. We then need to go into, I'll do this over here so you can see it. As we said, it's 1 directory per target. So sources core. And then we're going to go touch sources core. I'm going to create, I'm just going to call it app. We have our app delegate, now we just have app. So back over here, we can see we have our core target. We have an empty app.swift. So let's put some code in there. Now this looks much more familiar for everybody that does Swift iOS dev. Standard import foundation, standard app structure. We have a version property, and all we want to do is accept some arguments and run a function. Pretty straightforward. So the main entry point for your command line application is going to be the main.swift file in the module that's named after your executable. As you can see, default is to print hello world. So let's wrap that up into calling our core. So we import our core, and then literally remember that this whole file is not testable. Better. This whole file is not testable. Anything that's in this target is not testable, so we try to keep it as small as possible. And that's literally create a new app value. By default, we drop the first command line argument because in Unix programming, arg0 is always the name of the binary that's being executed, which is of no value to the code further down the tree. And then we run the app. Optionally, we handle exceptions. If you don't handle the exceptions, it's just going to print them out on standard error anyway. But let's print a nice error message that goes with it. Like, why not? Sweet, so we've done that. Let's go back up here. We can go our 2 main commands, Swift build, Swift run. So Swift build will go through, compile all of your sources that are in your directory. We'll link it up into a file in your .build folder. Swift run again, just runs it. So pretty straightforward. A good tip that it took me a while to figure out is that you can actually go Swift run, and then your package name will do the same thing. So that if we want to pass in command line arguments to our package, we have to do it this way. Because otherwise it will think that you want to pass it to the Swift run file instead of our binary. Sweet, so, and I'm out of sync already. Excellent. All right, so testing. Let's go back into our package.swift. This time we're going to add a test target. So, same again as before, except this time it's a .test target. And these are all just static methods on the package description and the package setup. We create a test target, we call it core tests. And because we're testing core, we depend on core. Same as you'd set up your next code. Same again, we have to, and this gets really annoying really fast, trust me. We have to create test folders. We're going to call it core tests to match our target name. And then inside core tests, we're going to create app test.swift. Cool. So back in my IDE, inside our core tests, empty app test file. Let's populate that. And this is very standard stuff, straight like XC test. If you've done unit testing for iOS, this will be very familiar to you. It's nothing different. Testably import our core. We create a test case. We run a test. Straightforward. So next command is, and I'm going to clear that so we have some more room, it's just Swift test. It should go through, compile all the changes we just made, execute our test suite, same as the output you'd see in Xcode. But that gets, a lot of this gets repetitive really fast. So the standard, oh wait, before that, we're going to use our imagination for a while and pretend that the rest of this is nicely tested, because I'm really not going to spend the time to write the test for you. We'll be here for like 2 hours, so.
That's where Git revisions are helpful. Go git check out all my tests.
Yes, that would be good, wouldn't it? Sadly, I'm not that prepared. I spent too much time hacking on my iPad app and not enough time doing my demo project. Sorry, Matt.
Which was quite appropriate.
Yeah. All right, so next up, to make all this stuff easier, we're going to go back to a standard C and Linux environment setup called a Makefile. So our Makefile is just a wrapper. So you can provide a target name, and then it will execute some command line argument, like command line programs to, usually for building. So let's go into our nice empty Makefile, same as always. And we're going to add 3 targets. Just a build wrapper, a test wrapper, but most helpfully as an install wrapper. And that will build a release version, a statically compiled released version of your app, and dump it in user local bin so you don't have to go and find it inside that debug directory every time you want to test it or to run it. So that's all well and good. So if we come back, default make, just wrap Swift build. We can make test. All good, test still pass, thankfully. And we can make install. So that'll go through, recompile it in release mode. Nice static binary. It's installed to user local bin JSON. And now we can run it anywhere. Now, but I miss Xcode. I said literally nobody ever.
I miss Xcode.
You miss Xcode?
I miss Xcode.
Of course you do, Matt. You miss not what I meant.
You asked for that one, Bob.
Yeah, I know. So one of the good things that Swift Package Manager does is it actually provides a tool to generate an Xcode project file for you from what you've got in there. So you can go back to using Xcode. And it's straightforward. Swift package, generate Xcode proj. Creates a lovely Xcode project file in our local directory, which we can then open. And then I can go ahead and get rid of TextMate. Sorry, TextMate. You've been replaced. Yeah, I like TextMate, I'm sorry. Sweet. We now have Xcode, yay. And we can build, and we can test, and we can get rid of the debug thing there. When that runs, whoa, that's small. That's test pass, that's fine. But be careful. Don't go messing around in Xcode. Don't mess with your settings, don't mess with your targets, don't mess with your schemes. Because as soon as you add a dependency to your package.swift and you have to rebuild your project, it's going to wipe everything. So it's treated as volatile. Don't mess around in there. Or if you do, as we will later on, just be prepared to let it know that it'll be destroyed at some point.
What about
Adding files is fine. Yeah, as long as it's in the right place, Swift Package Manager will pick it up. That's the main thing. Put it in the right place. Yeah. And it's SourceKit. We do this for SourceKit. As much as we load SourceKit, we do this for SourceKit. Cool. So next up, let's talk about print. Standard print function's fine for this sort of stuff. But good command line apps are supposed to, when they hit an error, supposed to write standard error, not standard output. So that way, if you happen to throw away redirect your output to dev null, you still have your error messages if they come through. But the good thing is that if you actually have a look at the documentation for the print function, it does actually support an output target. So the very last parameter on the bottom there is we can output to a stream, as long as it conforms to the TextOutputStream protocol. If we have a quick look at the TextOutputStream protocol, it's literally just a write. Takes a write method. Like, that's it. Which means that, and I'm still a bit miffed as to why they don't provide this out of the box, but a FileHandle, or NS FileHandle, if you're Oliver, provides a few standard input, standard output, and standard error file descriptors that are already available to your program. So we just add a couple of wrappers. One wrapper for standard output, checks for nil, obviously, just writes it to the standard output data, and ditto for standard output error. Cool. Got through that faster than I thought. All right, so let's just go in, and since we can't really see this anyway, inside our core target, can you guys see that? Vaguely see that. So as you asked Jesse, yes, we can create files. Just make sure that if you're going to build it, your target is set correctly, because anytime you rebuild your Xcode project, it's going to default back to whatever's alphabetically first, which gets really annoying really fast when you do all this work and then source kit's not working, your code won't compile. It's like, oh yeah, targets. Same old. So let's do some logging. Cool, we have a nice logging function. Let's replace this with, so we're putting into our code our stream output wrappers that they're on the left-hand side. And we also have a nice, simple log function. Takes an optional prefix to display before the log message. The message body itself, we're using the same as the print function, and we're just going to accept any, and then just take a string describing that any. But we also have a target enum. So we're literally just compact mapping down the message into a single string, and then depending on the target, writing it to standard output or standard error. So that means that we can go back up the top, create some nice simple public functions, and remember that this is inside a module, so if we want to use it elsewhere, it needs to be public. Standard log. I like to have a log header as well, just something that makes it more obvious that we've just changed what we're doing. Warnings, which are written to standard error, and then actual fatal errors, which are written to standard error, and then we die. Nice and straightforward. Any questions on that stuff before I move on? No? Hopefully that means everybody's understanding and nobody's bewildered. Seeing a few smiles down the back, so hopefully we're okay. So let's talk about command line parsing, since that's the... Yes, Flas?
Question.
Yes?
Why would you exit from a log function?
It's intended to be an analog to the fatal error normal thing that you'd normally use. In this case, it's usually just an example. That B is empty. So command line parsing. I come from, same as Jesse, I come from a PHP background and a bit of C background. Standard for command line parsing is getopt. So I did some research as to what the best approach for this is, whether there's some other magic third-party library or you roll your own. Nobody wants to try and deal with an array of strings that could be in any order and then include subcommands and their arguments and try to make sense of that. Luckily, if you have a look at the Swift package manager on GitHub, and that's a bit hard to see, the Swift package manager on GitHub, they actually do expose in their package.swift 2 library targets, so that a lot of the functionality they use internally, including command line parsing, you can actually just pull down from Swift package manager and reuse. Note the big bold warning that says this is an unstable unsupported API, use it at your own risk. Don't put it into production, basically. But it's there and it works. And a lot of the other ones that are, a lot of the other packages that I've seen, or command line apps that I've seen, depend on this anyway in the long term, because this seems to be the way forward for the now, until we get something properly supported. So, chief amongst that, and what we're looking for here, is a utility or a class, I think it is, called ArgumentParser. And as you can see, it takes in an optional command name, and then some usage description that gets displayed when somebody calls for help on the output. So, step one, let's go into our package.swift, and we're going to add a dependency. Why did you open in a new tab? Because I double-clicked. So let's go in and add a dependency. So we're going to depend on the Swift Package Manager, because why not? And now we find out how well our internet connection works. So Swift package update, same as you would Carthage update or heaven forbids CocoaPods. Git sub, no. Hooray, internet works. I don't have to use my backup. Cool. So we now have, it's pulled in the dependency. If you want to see it, it lives in the .build folder under checkouts from memory. Yep, so that's the Git repo and then a few other things that live in there as well. What we can do now is Swift package, generate, I should have added hotcode for this, generate Xcode project. Warning, oh yeah, we haven't actually added it to our package.swift. So we've we have imported the dependency, or we're dependent on it, but we haven't used it anywhere inside our targets. So where we're going to use it is inside core, because core is going to handle the command line parsing. So if we go back to that one, you'll see we're going to depend on the utility, which is a smaller subset and not the entire Swift package management thing. We really just want basic and utility and their dependencies. And a lot of those dependencies are around Linux compatibility, but that's okay. Cool, so let's try that again. Sweet, we have a new generated Xcode project, and it might be hard to see, but we have a dependencies folder now which has Swift Package Manager in it, which means we can now go to app.swift. Whoops, that's not the right paste. And we can start importing stuff from Swift Package Manager. So we want basic and utility for what we're looking for. We're then going to start building up an argument parser. Now, most of what argument parser does is done with equality, so this might seem a little bit weird, especially did to me for the first time, but it is what it is. Am I up to the next one? Not up to the next one yet. So let's replace our init. And we create a nice, pretty internal one so that we can dependency inject later on for our testing. But we really just want to create an argument parser with usage info and with the overview. But this is all for the help screen, basically. We then will add in options and commands to it after. So that's where I'm up to there. Excellent. So they also provide in ArgumentParser.pass. That's confusing to say really fast. So let's create a pass method, which really just takes our command line arguments, throws it over to ArgumentParser, returns the results. And the results are then used to do your matching in a second. So let's replace our run function with, we started building it up. We're going to ask ArgumentParser to pass our command line arguments in. Can you see past me, Oliver? Enough. And to make things nice, we're going to catch any argument parser errors. So they've included an invalid option or an invalid subcommand. And they also provide a nice print usage function so that you don't have to go through and then build up the print something, I don't know, words. So we've done that. Where am I up to here? We've done that. Cool. So let's Swift run. So you can see we've changed our message from hi mum to hi dad. So now we get to go through and we wait for Swift package manager to build, which is an excellent time for beer. Yep, you would have seen that. I haven't done anything with the options yet, but that's okay. And then we're going to go Swift run JSON -- help, and we should get the output of the print usage command. So the help is built into Swift package manager. We don't have to add that ourselves. Cool. All right, let's add a version. Now again, they provide a option argument, and this is again done by equality, so we have to capture the results that Swift package manager gives us. But in this case, we want to call parser.add, documentation's on the left-hand side, with our version, -- version. It's a Boolean. We don't really care if they provide a Boolean or not. As long as their value is there, it will return true. You can also accept strings or integers, whatever you want. Anything that conforms to argument kind, which I haven't gone into detail on. And then the usage help. Yep, done that. Right. So now we come back down to our run. Now, so our options, which is the ArgumentParser.result, they provide a function on there, which is at the documentation at the bottom, or at least all the documentation they give you. You just call options.get. You pass in the result that we saved from the parser, and it does an equality check. If that option is actually set, it will return the value. If it's not set, it returns nil. So we're just checking if the version option is there. If it is, we print out the JSON version, and we exit. It's pretty basic. Our first command. Yay. So, where am I up to? I'm up to there. Cool. So if we come back over here and we rewrite our help, we should have a version command in the help. As you can see, switching back to terminal gets pretty old pretty fast. Fortunately, or unfortunately, however you might look at it, if you go in, this is the other thing, it sometimes jumbles up the order of your targets when you regenerate your Xcode project. So sadly, but with our executable target, we can go in and add, and this top bunch here is command line arguments for when we run it inside Xcode. So we can go -- version, and you might have to take my word for this because it's going to be hard to see. But if we build and run, we should print version number. And let's do this over here so you can see that it's true. Prints out version number. But that also means if you're testing a certain path in your command line code, just add your arguments into the scheme, and then you can just build and run inside Xcode. You don't have to keep switching back out to a terminal to test this stuff. Cool. All right, so I'm actually a bit earlier than I thought I would be. That's good. So let's talk about our first subcommand. So we're going to do input, accept some JSON input, and we're going to print it. Pretty straightforward. Hopefully pretty straightforward. See how well. All right, so back to our package.swift, which is our source for everything. We're going to add in our formatter target so that we can keep everything nice and clean, test it, blah, blah, blah. We need to make sure we depend on it. I forget this step every single time I practice this demo. Multiple times I practice this demo. Usually Swift will complain when it can't say, hey, you're not actually using this framework that you've added. So, and then the other step that I always forget, we need to go and create the directory. So if we then go and Swift package generate Xcode proj, it will generate it, but it will say, hey, there's no actual source files in there because we forgot to, what do they call it? JSON formatter. Sweet. So if we redo that, should be able to come back to our project, and we should be able to go to sources, formatter, JSON formatter. Sorry, TextMate. Again, lovely empty file. Let's fix that. So again, pretty straightforward. Importing foundation, creating a JSON file structure. We really want to just accept. Like all we want to do is get some JSON in. We're going to use the JSON serialization API, not Protable, because I don't know what the structure of this JSON might be. It could be arbitrary. And then we have our structure here, which is really just wrapping up. There's a nice way to wrap up the JSON serialization options so that you can pass them from your core target library over to your formatter library. And small tip, when you have a, for each library target, have a unified error API, which literally just wraps any other errors that your code might throw. Why? Because if you're trying to debug something that a user sent you, literally all you're going to get from them is the copy and pasted output from the command line, and all that's going to say is, hey, file not found error. Great, where? Which one? Like in the 10 places that I call the file system, which one was that? So at least if we say, hey, we can't serialize this because there's a serialization issue with the JSON that comes in, we've got a little bit of context that comes back with it. And it's also good for iOS apps too, just for the record. Cool. Go back to our pretty subcommand. Where am I up to? Yep, cool. That's done. So all we want to do is to accept data from our core. Very basic initializer, accepts a JSON, optional JSON string for testing, or for if you wanted to be able to bring that in via a different method in the future. And our options from the command line. Happy path, if we have JSON data, we just try to deserialize it. But the key thing actually for this part is if JSON string's nil, we attempt to read from standard input. Now, one thing that this doesn't do is that if you are, for example, cutting dev random, or you're attempting to tail a file, a stream that never ends into this application, that's going to sit there attempting to read the whole way through. So you need to be a little bit better about handling that. Treat it as a normal stream and process it as it goes. But for a JSON application, if the structure never ends, then it's going to chew up all your memory and die anyway. Probably set fire to your building, but you know. Cool. Oh yeah, and the other thing we need to do, now that we've captured our JSON and the output options, is to actually print it. So that's literally the only thing that this module does, is to print that out. And the good thing about this is you can pass in a file handle. So if in the future you wanted to add the ability to output it directly to a file, you only need to replace in the pass in a different file handle to this method. If not, it defaults to standard output. And yeah, standard JSON serialization, grabs the data, writes the data. Easy. Easy, well, yeah. Cool, so back in our core, if we go back to app.swift, so what we're going to do is, now you can do this any way you like. I like to have a nice simple protocol that defines my subcommands. All I really need to know is the data that I pass to ArgumentParser, which is the name of the command, the help text for the command, and hey, I want to be able to execute you with the input from the command line. So then if we go to app.swift, we can add in support for this sort of stuff we're going to accept. We need to keep an array of subcommands because ArgumentParser works off equality for some reason. Oh, there we go. My subcommand file is in the wrong target because it defaulted to basic. Another mistake I made every time I did this demo. That should work better. Yep, cool. But now we need to initialize our subcommands. Whoops. Let's do this with just an empty array of subcommands for now. Yeah, I've done that. And then finally, the only other thing we need to do, oops, no, two things we need to do. We'll add a function to grab to attempt to grab. Let's get rid of that. Takes in the result from our parse function, so we have the command line arguments as known by the argument parser and Swift Packages Manager. We then call, when did I do that? No, I didn't do that. Off by one error. They provide us a subparser function, so the results from the command line argument, you can then pass in the main subparser again, and it will tell you the name of the subparser that it used to process that. It's a little bit convoluted. This is why it's unstable and unsupported. But at any rate, so we're going to get back, hopefully, the subparser that was used. It's an optional, of course, so if it's not found, it's not found. And then we're going to match it back to our array of subcommands that we saved before. So then we need to, so literally our core program is check if there's a version argument. If there's not a version argument, check if we have a matching subcommand. If there's no matching subcommand, we display, hey, invalid subcommand or option. And then we print the usage, and then we die. That's it, because the program did not execute successfully. Error 400, bad user input. If we do get one, we run it with the input from the command line. So that keeps it nice and clean, nothing else to do there. So did I do anything at that point? No? Aha, a whole page of things I missed. No, not really. All right, so let's create our first command, because that's what we're here for. And then we can all go home. We're going to change our target. That's better. And then so we're going to create a pretty subcommand. Nope, wrong paste buffer. Here we go. So again, it's literally just implementing the protocol that we had before. We provide a name, we provide an overview, which is used in the help. And this is the only thing that's a bit weird, is that we accept in the main argument parser, and then we add ourselves as a subparser to the main argument parser with the name and the overview. And we do that because we need to keep a reference to that subparser so that we can actually do our own options matching later on, which is very weird. Where am I up to? 35, 36. Awesome. So we're going to add in one option to this, not with that paste buffer. So our original, we didn't see it on the original slide, but we can provide in a sort our output so that we can see what options look like inside a subcommand. Now, strangely, or not strangely, deliberately chosen, NSJSON serializer's sorted key option was only introduced in macOS 10.13. Unfortunately, all of your Swift command line apps are targeted at 10.10, and it is really difficult to actually overwrite that, so you're better off just conditionally compiling stuff, sadly. That's why we have it as an optional. So if you're in 10.13, we add in the sorted option. Before that, we just don't support it at all. So that's that code, that's that code. Oh yeah. So now we need to have our run. So when we actually execute this command, literally all we want to do, not with that paste buffer. I skipped a step, that's why that paste buffer's there. Uh-oh. Error. No, that one. There we go. So same as what we have to do in our main command processing, we have to do our own checking of the subcommand options. In which case, by default, we want to pretty print this, so we're just going to set pretty printing as our standard for this command. If we're in iOS 10.13, iOS, macOS, and they've provided the sort option, which is -- sorted. We insert that into the writing options, and then we return that option subcommand, that options structure that we created previously. And then to execute, now we're back on track. We get our options with the argument results. We created the JSON formatter structure with the options that we found, and we print. And now, if I'm down to here, that means I can go, the other thing that I always forget. So back at app.swift, in our array of subcommands that we have here, we need to add a subcommand, obviously. So because it's self-contained, we just need to go pretty command, or pretty subcommand, with use your paste buffers. So that's it. We now have a pretty subcommand. We can now go back into, let's do this the nice way, make install, hope that this compiles. Come on, be happy. Yeah, this is from 2012. It's not good. You'll notice I'm plugged in just because the battery lasts 3 minutes. If anybody wants to sponsor me a new MacBook, I'm all here. Right, so we now have a JSON binary. Ugh. And now it has beer on it. This is excellent. Cool, so we have a JSON binary. If we do JSON help, we can see we have a pretty subcommand. If we do JSON pretty help, we can see it has an option. So we can now go, cat in our demo JSON, pass it into JSON pretty. Wait, let's show you what's in it first so you don't see there's any trickery. JSON data, not sorted, not pretty. Well, I don't know, I kind of like how that looks rather than how Xcode thinks pretty looks, but anyway. So let's do that. Pipe it into JSON pretty. Ta-da, output JSON. Hooray. And we can sort it, which just alphabetically sorts it. Cool, so I'm running over time, so I'm going to skip several sections of this next bit, because you won't want to see that. Let's do rendering, because this does something that's actually really cool. Now, how far is my paste buffer out of whack? Oh, closer than I thought. All right, so let's go into package.swift. So this last bit, we're just going to look at executing other commands and then displaying the results. That's pretty much it. It will be quick. So let's create a target called renderer, which has no dependencies. This is the trouble with my paste buffer being out of sync. We need to make sure we depend on that target. Render up. And then we need to make sure we create the directory, touch source files, regenerate the package. So if we go into our renderer.swift, render.swift, which is nice and empty. Same as before, this is really basic. It's just going to be accept the JSON input Now we don't care about the structure because we're just literally going to accept data and send data. We take a template path, so we need to know which template to use to render this thing. As before, we get the data from standard input if it's not there. We have our output function. And then, to actually output, no, one ahead. Yep. So Swift, again, Swift Package Manager provides a nice set of classes for handling, executing stuff on the command line. Sadly, it doesn't support standard input, so I have no way of echoing output into that process. So our wrapper for that, well, so our templating engine we're going to use here is just, it's called Mustache. It's very common. It has libraries for every other language under the sun. But it accepts on the command line a JSON file or a data file that you can then push in. So all we need to do is use the temporary file structure that Swift Package Library also supports. And we're going to do that here. So it's literally just returning a temporary file and encapsulating that error if it's not found. So to build up our output function, we get a temporary file, we write in our JSON data to that temporary file. And the good thing about this temporary file is that, as the note says, the file is deleted as soon as the class or the object itself is de-initted, so that you don't have to worry about cleanup. Just means that you need to make sure you have a strong reference to that. Otherwise, your temporary file might get deleted before you expect it to be finished. So now we've got a temporary file. The process class, we just want to init a process. And it's literally the only thing you need there is the command line arguments that you want to pass to the process, remembering that the 0 index must be the name of the binary or the full path to the binary that you want to execute. Nope, wrong paste buffer again. So that's literally it. We want to call the Mustache. We want to provide the path to the JSON file. And we want to provide the path to the template. The other thing we need to do is we need to process the output. So we launch the process here, and then we get our results back. Now the structure of the results file is on the left-hand side. It just returns an exit status, but the things we're interested in are standard output, standard error from the process that it launched. So we get standard output if there's standard output, and then we capture that. We write it back to our own output handler, whatever that might be. As before, it defaults to standard output. Otherwise, we attempt to find whatever's in standard error, output that. Oh, that's well gone. Cool, so we're at the very last stretch here. I can see Matt's falling asleep. You have too much beer, Matt? Yep. Yep. So all we need to do is, we need to create a render subcommand and change the target, because of course we do. Render subcommand. Nope, wrong paste buffer. So our render subcommand is exactly the same as the ones you saw before, except there's no such module renderer. Why? That's interesting. Uh-oh. This is what I get for skipping things. There is no dependencies because it's internal. If in doubt, regenerate. I'm in core, right? I'm hopefully in core. Nope, build still failed. Excellent. Oh, great. This is going to be good, isn't it? Let's go find out my paste buffer and what I should have had in there. Of course, in our package.swift, renderer, actually, because we're using the Swift package manager, we need to depend on utility as well. That'll work better. Build still failed. Oh yeah. That one's actually a proper error. Yay! Saved. But now I'm way off in my paste buffers. Oh, cool. So literally the only paste buffer that's left is in our app.swift. Let's get rid of that thing. We go in and add a render subcommand. So then we can go back here, we say make install. You can see we have 2 subcommands now. We have a render subcommand that takes a positional argument. Positional argument is the same as the other arguments that we saw, except it doesn't have an option flag in front of it. It just takes the first one off, like the first string coming off the array. So if we go get demo.json, pipe it into JSON render /demo.mustache, and we're done. That's it. Oh. Apologies, that took a lot longer than I thought it would. But so there was one last thing. Just a heavy reminder, there's no run loop, which means all of your nice asynchronous code will not get executed. You can either create your own run loop. Swift Package Manager provides a nice async function as well if the function that you're calling has a callback with a single result. Or they also have a condition which wraps NS condition. But most of the time, for us, pretty standard, just create your own run loop. Cool. That's it. Any questions? Yes?
Swift Package Manager, is it going to solve all of our problems?
No.
Yes.
Well, ask me again in a month.
This generating Xcode projects, it seems to, the format of the file structure that you put in there seems to be a convention. It seems like everything, you've got a dependency there from GitHub. It seems to be everything I need.
Does not support iOS.
What do you mean?
You can only generate macOS command line stuff with it at this stage, and other frameworks. You can't actually go and use Swift Package Manager for anything that you're deploying via the Mac App Store or the iOS App Store. Well, WWDC is in a couple of weeks.
I'm really hopeful. If I'm excited about anything next month, it's Apple's native fast-lane edition that does
Thing is that, I mean, like,
Yeah, no.
VM, it's all public, that's all about the public. Like, it's, like, the copies, it's not, someone can furiously, like, wait for shit.
Private forks, it's GitHub. But Swift Package Manager might be open source. Xcode is not. And that's where we're falling down because there's no Xcode integration for this stuff. Yeah, feel free. It's like I said, it's open source. Go feel free to make a pull request. Do all the work for Apple and don't get paid for it. But it might be more effective than opening radars, so.
You mentioned that do not go and expect to change stuff in Xcode because we'll deal with it next time.
Yep.
Can you change something in Xcode, save it, and then copy the info P list with the parameters written and somehow be able to set all your crazy parameters?
Not out of the box. I'm sure somebody's tried that on.
I was just thinking maybe you could just
You could probably add that to, that's probably one of your key things that's good for a Makefile, is if you just want to copy out your info.plist and a few other things to somewhere else, saving your schemes, and then putting them back after you've run. But, it's certainly possible. Yeah.
I'm interested in how you perform presentations.
I'm glad somebody asked.
How'd you do the cool?
So clearly I wanted to keep, so the goal was to keep, right, the slides and the text editor up the screen at the same time. Sadly, Keynote does not like full screen. Regardless of what you do, it's going to do its own full screen. So that's actually a PDF that you see running on the left-hand side. Sadly, Preview is not Apple scriptable because I don't know. So it's using a open source PDF app called Skim, which does support AppleScript. And then the magic is multi-peer connectivity framework. So you would have potentially seen there is a very dodgy app that I wrote that literally just starts an advertising and stops the advertising, and that's it. That's just advertising a multi-pair connectivity service called Prezzo, because why not? There's no encryption. Like, anybody could have just jumped onto the Wi-Fi and then started joining the session and sending commands, because, hey, I did this in like half an hour. And then this is just two instances of PDFKit's PDF view. And as you tap the buttons, it just sends through commands on multi-peer connectivity to the main one.
And this is just full screen side by side.
Yeah, so that's just the PDF full screen in single page mode. So all it does, yeah, and then that's just the terminal. So you can see at the top. Yeah, I probably spent more time working this out than I did on the actual demo, but sure. It does all right. I need to get the font sizes a bit better because it was a bit small on the day, but yeah.
That's as impressive as when the first tech set presentation was given. So like, wow, how did you do that? Yeah, it's just in Markdown. This takes the next level.
So, well, it's funny you mentioned Markdown actually, because the whole thing is written in, except for the slides themselves. I don't know if you guys follow Erica Sadden on Twitter. She tweeted the other day about a new app called Snippety. That's what lives in the menu bar that I had up top there, which has all of my paste buffer in it. So that's literally everything that I went through just then. There's a global shortcut key to advance and grab the next paste buffer, and then we just paste. And then I have my lovely cheat sheet, which reminds me of which buffer is on which screen. And so next version of this, I wrote the slide numbers on my form, but I don't actually have the slide numbers on the app, which is an oversight. The off by one error is really annoying, so it doesn't actually show the second slide until you get to the third slide. Yeah, there's some work to do. It's not even an alpha. It's just.
Answering my question.
Sure.
More thanks for being prepared for it.
Yeah, well, I figured somebody would do that. But happy to say, experiment was a success. When I just tested this at home, it froze my MacBook, and it took me 20 minutes to get set back up again. So
This was a double demo.
it was a double demo, yes, I suppose. Cool. So any more questions, or can I throw to Jesse and we can go home? Jesse, let's go home.